This video is brought to you with support from my patrons on Patreon.
Hey everybody, it's Jimmy from the DIY and Digital, and today we're going to make this run all by itself using this. Welcome back everybody. Today I'm super excited because I've wanted to do this project for a while. I actually had it on the books to do about this time last year, it just didn't work out. So I finally am getting to the point where I'm able to do this project, which is a completely automated railroad. In this case, I'm using this to automate this little Kato streetcar to go back and forth and stop at a little station in between. So this is going to have an auto reverse feature as well as some automation where it stops at a station for a certain amount of time and keeps going. This is actually based off of a couple different previous tutorials that I've done, and I'm going to link those at the end of the video as well as in the description below. Let's go ahead and hop into the build.
Before we begin, I know a lot of you are going to wonder where this came from. This is a Kato Pocket Line Series Tram. They do not sell this in the US. It is DC and I ordered it from Japan. I will put a link in the description below to where you can buy it. Here are the parts you're going to need for this build. You're going to need, of course, an Arduino. I'm using an Uno in this case. You're going to need an L298N motor driver to control the train itself. And then you're also going to need at least one breadboard. I'll be using two, a rotary potentiometer, 3 infrared sensors, a bunch of DuPont wires, and a resistor right around 440 ohms. The first thing we need to do is to take our power connections from the Arduino and set them up on the bus columns of the breadboard. That's the red and blue columns right here. This will make it easier for us to connect power later. Next, I'm going to bring in a second breadboard. Now the second breadboard's optional, I'm just doing it for this part, but I'm going to go ahead and put my rotary potentiometer on this breadboard, just to make it easier to control. Now I'm going to go ahead and connect my infrared sensors, and the first thing I need to do is connect power to them. Now when we connect power to them, we're going to be running from that bus column that we just set up, and we're going to run it to the VCC and GND pins on the infrared sensors. Next, we're going to go ahead and connect the sensor output of the infrared sensor to the Arduino at analog pin A0. We then just repeat the process for the second and third sensor, hooking it up to A1 and then the third sensor up to A2. Now it's time to go ahead and hook up the rotary potentiometer. The first thing we're going to do is connect its positive power. So we're going to connect this pin to the 5-volt column on the bus column. Next, we're going to connect the sensor output, which is this pin, over to analog pin A3. Now for our ground connection, we are going to need to put a resistor in this, and the ground pin is the middle pin on the rotary potentiometer. We're going to use a 440 ohm resistor for this, and then we're going to connect the other end of the resistor to the ground side of our bus column. Next, we're going to connect the motor driver controls to the Arduino so that the Arduino can control it using the sensors and the rotary potentiometer. We're going to connect this to digital pins 6, 5, and 3. Now this is an L298N motor driver, and the first thing that you need to do is on the control pins, you need to remove this little jumper right here, and it just pops right off. Next, we're going to connect 12 volt power to it, and that goes on the marked 12 volt and ground connections, and I'm going to be using this little barrel plug adapter that I've put some jumper wires onto just to make it easy to screw in place. But you just need some sort of connection right here to the ground and 12 volt terminals. Now that third pin on the terminal right there is actually a 5-volt output connection that you can use to power the Arduino, and I plan on doing this in a later setup. The next thing we need to do is connect our output to the track, and that is going to be outputs 1 and 2. These motor drivers can actually control 2 motors, and we're going to be using the motor number 1 position to control our train. And all you gotta do is just connect the 2 feeders in there. It doesn't matter which side or which color you're going to do, it's just output 1 and output 2. Just know that this will affect the direction that we are going to be going in the train, so you may need to do some rearrangement of the sensors depending on which way you wire. Alright, so now it's time to connect our control pins from the Arduino to the motor driver. Now, pin number 3 is going to connect to the pin that we just removed the jumper from, which is called, if I can read this because it's really small, it's EXA or EVA or ENA. It's one of those 3 right there. It's so small that I'm having trouble reading it. And pins number 5 and 6 are going to connect to N1 and N2 respectively. You want to make sure that you get those all correct, otherwise your train's not going to run. So again, the wire coming from pin number 3 on your Arduino is going to connect to that A pin, that EXA or ENA, whichever one. And wires coming from pins 5 and 6 are going to connect to N1 and N2. You don't need to worry about the rest of them because that is the control points for the second motor, which we're not using. So those are all of the connections. We'll go through the setup of the track here after we do the code.
All right, so there is the build. I'm super excited to get this working, so we need to do some coding. All right, everyone, we're in our Arduino IDE, and it is time to write some code. So the first thing we're going to do is we're going to write some integers. So I'm going to do int station 1. Now, don't worry about that. So we're just going to designate each one of our stops as stations. So we're going to do int station 2 and int station 3. So since we only have 3 stations, if you had more, you would add more right there. Next thing we need to do is int speed. Now the capital is very important in this because if you do a lowercase speed, it's actually a function within the Arduino IDE. So we have to do capital, and that's the same way with the next one, which we're going to do int direction. We have to have that capitalized as well. And then we're also going to do int speed val. And there we go. That is all we're going to need for our integers. So let's go ahead and go into our setup. We're going to go ahead and delete the line that's always there. And we're going to start with serial.begin parentheses 9600. Now we always do that so that it can just start reading the sensors and giving us a readout in the serial monitor. So, all right, so let's go ahead and do pin mode parentheses 5 comma output, pin mode 6 comma output, and then pin mode 3 comma output. Now what this is basically declaring the 3 digital pins that we are using in this sketch. It's going to declare them as outputs because they're all outputs. We don't have any digital inputs. All of our inputs are analog. Now that is everything we need to do in the setup. Now if you've done some of my other Arduino projects, you know we do quite a lot in the setup. This is actually a fairly simple sketch. So we're going to go ahead and hop down into the loop. So the first thing that we need to do in the loop is we need to get readings for all our stations. Now we know that stations 1, 2, and 3 are plugged into A0, A1, and A2, and we also know that the potentiometer is plugged into A3. So what we're going to do is we're going to do station 1 equals analog read parentheses A0. And then we're going to do station 2 equals analog read A1. Then station 3 equals analog read A2, and then station 4 equals, oh no, sorry, not station 4 actually, we have speed val. I got to type in there, speed val equals analog read A3. Sometimes you just get type in there and you just kind of get in the zone right there. All right, it's time to get what our speed value is. Now remember, we're setting our speed with that little rotary potentiometer, and the way we're doing this is basically that signal is coming into analog pin A3, and we're storing that as speed val. So that's going to be anywhere from 0 to 1023. And we need to take that value and map it to a 0 to 255. So you're trying to get the same percentage of speed ratio of the number and take it from 0 to 1023 and put it on 0 to 255. Now the reason that we have to do this is because the analog to digital converter that allows for our analog read function, that device is a 10-bit device, which means that in binary is if every digit was 1, that's 10 ones, that equals 1023. Now the pulse width modulation timer, PWM timer, that does the analog write function is an 8-bit device, which means that if in binary all the numbers are 1, the maximum value is 255, which means that's why we have to convert the 0 to 1023 to 0 and 255. I know that's a lot, and that's a lot of inside baseball, but let's go ahead and knock this out. So we're going to go ahead and type in speed, and then we're going to do equals map. So basically this is going to take our 1023 and map it to 255. So what we're going to do is we're going to do speed val, comma, 0, comma, 1023, comma, 0, comma, 255. And that will transfer our value over into an output. And then we're going to go in and we're going to do analog write, parentheses 3, which is our control pin that goes to the L298N motor driver. And then we're going to tell it to write whatever speed is. So whatever value is being saved as speed, which is what is going to be coming through, is going to be written to the motor driver, and it's going to output it to the track. So now we want to do a few things just to double check. I don't need to write all those values, but what I'm going to do is I'm going to do a serial.println direction, and we're going to use that in a minute. And then serial.println speed, just so we can make sure that it's right, because you may need to tweak it a little bit. And then we're going to do our normal delay of 200. I just like doing that. That's a preference. You can change up your delay. All right, so now we're going to go into our if-then statement. So let's go ahead and go into our first one, which we're going to do if, this is for station 1. So we're going to do station 1 is less than 500, which is pretty much a halfway value that it's going to go really high or really low. So that's going to be our midpoint for if the sensor gets tripped. We'll do digital write 5 low, digital write 6 low, and then we're going to do direction equals 0, and then we're going to do a delay of 5,000. Don't worry, I'm going to explain all of this. Digital write 5 comma high, digital write 6 comma low. And then we're going to do another delay, and this one I'm going to do is 1500. Okay, so now let me explain this really quick. Of course, at the top we have station 1 is less than 500, which basically means that the infrared sensor is being tripped, which means that the train is in front of it. it's going to do digital write 5 comma low and digital write 6 comma low. That's going to cut all power to the motor driver and tell it to stop sending any power to the track. Then we're going to have direction equals 0. This is a variable that I am using to be able to change and identify which way it is going. So it's either going to be a 0 or a 1. So in this case, it's going to set it to 0. And then I have a delay of 5,000. Now, if you remember with Arduinos, that time is measured in milliseconds. So that's a 5-second delay. You can set this however long you want. You just remember that ratio. Then I'm going to set it to digital write 5 comma high and digital write 6 comma low, which is going to initiate its direction. I can't really tell you which direction it is because it really depends on which way you have it wired, which way and where you have the station. So you may have to do a little bit of guessing and checking on where you position each of the end stations. So if they decide to try and send the train off the edge of the track, you know that you need to flip the stations to the opposite side, which you can also just flip the pins reverse on the Arduino, which is a lot simpler. So that is for station number 1. Let's go ahead and go to station number 2. So we're going to do if station 2 is less than 500, do our brackets. We're going to do digital write 5 comma low, digital write 6 comma low, and then we're going to do direction equals 1. And that's where our variable changes that tell us that it's about to go off in the opposite direction because it's reached an end. Then we'll do a delay. I'm doing 5,000. You can do however long you want. That's just the time of the stop. So a quick little 5-second stop and heading back. Remember, I'm not trying to be realistic with this. Then we're going to do digital write 5 comma low and digital write 6 comma high. Now what this is doing, basically you can see that it is opposite of station 1, which means it's going to send it back the opposite direction of the first stop. So that's what we're going to do there. Now we're going to go to station 3. Now what I'm doing here is basically anything that's beyond station 1 and 2 is a station in the middle. So we're going to go to station 3, and if you wanted to add more, you certainly could add more. It's really not that hard to. Okay, so station 3 actually requires 2 separate if-then statements, one for each direction. So we're going to do if, then we need to do a double parenthesis, station 3 is less than 500. Then we need to do a double ampersand, which is and in Arduino language. Direction is equal to 1. Now, when you're looking at that and you see that double, that means equal to. Now, if you have a single equal, that kind of means like is. I went over that on the last thing, but that's basically how that works. So when you see the direction in the station 1, station 2, it's saying that direction is 0, direction is 1. So when you're checking it, you need to see if it's equal to it. So if station 3 is less than 500 and direction is equal to 1, we'll put our little curly Q bracket right there, and then we'll do digital write 5 comma low, digital write 6 comma low, then delay of 500. We don't need to change the direction because it's going to keep heading the same direction. And then we'll look at this and we'll say where direction is equal to 1, which means that station 2 set the direction as 1. So we need to have it going in the same direction as it did from station 2. So we need to do digital write 5 comma low, digital write 6 comma low, and then a delay of 1500. So, whoop, I forgot we need to put that as high, not low. Almost messed up there. So what we have here is we have station 3 is less than 500 and direction is equal to 1, which means that the middle station in our case has been tripped, and the direction is equal to 1, which means that it was coming from station 2, and so it cuts the power, delays for 5,000 milliseconds, a few little typos there. And then it goes to digital write 5 low, digital write 6 high, which is identical to station 2, which means it's going to keep on going in the same direction. Okay, so now we need to do one for if it's coming from station 1. And that's really easy to do, to the point where we can literally just take this, copy it, and paste it. And then we need to make a few changes to this. So what we're going to do is, if direction is equal to 0 instead of 1, cutting the motors is fine, so we can leave that as is. We can leave the delay 500 as is, so we just need to reverse the digital write 5 low, digital write 6 high. So we're going to go digital write 5 high, digital write 6 low. And that is everything. Now, if you wanted to add additional stations, let's say you had more than one, you would need to go in and simply add some more integers, and you would have to add some additional sensors. So let's say you downloaded the sketch and you wanted to add another station. All you have to do is go int station 4. We'll go in here and we'll say you hooked it up to A4, so we'll do station 4 equals analog read A4. Then we would need to, what we would do is we would literally copy all of the station 3 stuff, and we would just go and change it to station 4 and station 4. And it's that simple to add stations. So you could theoretically add as many inputs as you have. You could even, if you really know your stuff, you can go ahead and change these to digital inputs and outputs. Use Omega, and you could probably do a whole city's worth of stops. But that is basically how you add additional stations to it. It's really, really simple. So, but I only have 3 stations, so I'm going to go ahead and take this back out. Go ahead and close that back. Take out everything just to be safe. Now we're going to check it. There it is. Let's go ahead and upload it. All right, we've built it, we've coded it, we've loaded it. Let's get the setup done, and it's a little bit trickier than usual. All right, we have everything set up right here. You can see that I have my 3 sensors at what would be the 3 stations. Now remember that the sensor that is connected to A0 is one of the end stations, and the sensor connected to A1 is another one of the end stations, and the sensor connected to A2 is that middle station. And now a couple things to note to start this. The train does have to start at one of the sensors. It can't just start in the middle, but once it is off and running, it will go completely automated. You can adjust the speed. You may see a little bit of a jump as it comes out of its clear state. And also, if your train decides to go the opposite direction of what you want, you may need to reverse which side your end stations are. So if you're at the left side station right here and it wants to keep going left rather than go back to the right, you just need to simply reverse where those sensors are for the end stations. But you can see right here that this is working right here, and I absolutely love this. I've been wanting to do this for a long time. I know that there's a lot of reversing loops and things like that, and reversing tracks out there for Arduino, but I really wanted to be able to add a station in the middle for it to work. So I hope you guys enjoy this. I am so happy with the way this turned out. This actually builds on a couple of other Arduino projects that I've done in the past, and like I said, I'm going to link those at the end of this video. I do want to say a big thank you to all of my patrons. They're listed right here. You can become a patron for as little as $1 a month. A lot of cool stuff going on over there, including a model of the month that you can 3D print yourself at the $5 a month level. Thank you all so much for watching. Until next time, I'm Jimmy from the DIY and Digital. Stay safe, be kind, and happy railroading. Up to this that were a while ago, and I wanted to link those right here, and I wanted to put those right here at the end. No. over there. And if you're at the $5 a month level, you get a model of the month that you can 3D print yourself. So be on the lookout for that. And why would I say be on the lookout? A little bit more learning, I'll link those right here at the end of the video. And if you are a person, I'm bad at this,